Relations and Functions, Algebra 1 EOI Review. Remember, this is the breakdown of the questions that will be asked on the EOI. Today we're going to talk about Relations and Functions Standard 2. Remember, this is the largest tested standard that we have. Out of the 55 questions, 31 of them are going to be over this standard, which means 56% of your test will be over these 4 objectives that it's broken down into. Today we're going to talk about Objective 2.1, which is Relations and Functions. Of the 31 questions asked, the ideal number of items over relations and functions will be 6. The first thing we need to talk about is linear versus nonlinear relationships. Notice I'm not talking about functions yet, I'm talking about relationships right now. So when we're talking about linear versus nonlinear relationships in graphing, if a relationship is linear, you're going to be able to draw a straight line through all of the points with no curves or turns. If you look at this first example, it says which graph shows points that represent a nonlinear relation. This should be pretty obvious, but I'm going to go ahead and draw lines through the points of all of these graphs to show you what the graph would look like if a line was drawn. So in graph A, when I connect the 3 points, I have this diagonal line. Notice I didn't have to turn or curve at any point. It's just a straight line. I could have drawn it with a ruler in one mark. B, however, when I try to connect those, I have to curve or turn. C, I can connect with a straight line, and D, I can also connect with a straight line. So the graph that is a nonlinear relation would be B. It's the only one that I had to turn when I was connecting the 3 points. A linear versus nonlinear relationship found in a table, it says if a relationship is linear, the x and y values will increase or decrease at a constant rate. The slope will be the change in y over the change in x. It's very important that you check to see if the relation or if the constant increase or decrease when you write the slope change in y over change in x. It would be important to see if you can simplify any of those to become the same slope. Now, one thing that I want to point out is that x and y values have to increase or decrease at a constant rate, but they don't have to be increasing or decreasing at the same rate as the other. So x values have to increase or decrease at a constant rate, and y values have to increase or decrease at a constant rate, but they don't have to necessarily be increasing or decreasing at the same rate as each other, x and y values. If you look at this example, it says which set of data represents a linear relation. For A, we're just going to find our pattern starting at the top, going to the bottom for both x and y columns. So for table A, my x values are going to increase. First we increase by 5, then plus 10, then plus 5. My y values are increasing by 3 each time. Which means this is not going to be a linear relationship because my y values are increasing at a constant rate, but my x values are not. In table B, my x values are all increasing by 2 each time I move down, and my y values each increase by 3 as I go down. Notice that's what I was talking about. They're both constant, but they're not the same rate as each other, and that's fine. So for right now, I think my answer is going to be B. I'm going to go ahead and double check and make sure that C and D do not work. For C, the x values increase by 1, and then by 2, and then by 4. And then my y values increase by 3, and then 12, and then 48. Now, if I went ahead and tried to put change in y over change in x there, just to make sure it can't be simplified to be the same, first I would put 3 over 1, so the slope would be 3. Then I would put 12 over 2. Well, 12 divided by 2 is 6. A slope of 3 and a slope of 6 are not the same, so C is not going to be a linear relation. And then I'm going to go ahead and double check D. I increase by 2 and then 1 and then 2 on the x values. My y values increase by 10 and then 6 and then 9. And notice these would not be simplified to be the same ratio. 10 over 2, 6 over 1, and 9 over 2 are not going to be give you the same slope. So my best answer here is B, is a linear relation. The slope of that line, just a little side note, would be the change in y, so 3, over the change in x, so 3 over 2. For a relation to be a function, each input can have only one output. So if you look at this example, it says which relation diagram represents a function. If you look at the inputs of diagram A, you notice 0 has one output, 1 has one output, but when you get to 2, notice it has two outputs, both 3 and 4, which means this cannot be a function. In example B, notice -1 has one output, 2 has one output, 3 has one output, and 5 has one output, meaning that this could be a function. Notice both inputs 3 and 2 have the same output 4. That is fine. That can happen. It's that one input can't be split between two outputs. So B so far looks good. Go ahead and check C and D just to make sure. -1 has one output, but when you get to 0, 0 has two outputs, 1 and 3, meaning it cannot be a function. And then same thing with D. -2 only has one output, 4 only has one output, but 0 has two outputs, both 4 and 5, so it cannot be a function. So my answer here is B. The vertical line test. For a relation to be a function, its graph has to pass the vertical line test, which means that at no point on the graph can a vertical or up and down line pass through more than one point. You're going to want to use the vertical line test when you're given graphs of functions. Otherwise, a mapping diagram or relation diagram, like in the last example, will probably be your fastest way to determine if a relation is a function or not, just because you won't have to graph all of the points and then do the vertical line test. That can take a while, depending on the numbers and depending on how many points you would have to plot. So in this example, it says which graph represents a function. We're given 3 separate graphs. What I'm going to do is I'm going to pass, if you notice these red lines, I'm going to go ahead and pass the red line through, and then we'll come back to a spot. If it's not a function, we'll come back to a spot where it's passing more than one point. So if you look at graph A, watch this line go through the graph, and at several points through that graph, it passes more than one point. As a matter of fact, anytime it's on the line, it's passing more than one point with the exception of right on the very edges on either side. So A is not going to be a function. It does not pass the vertical line test. I'm going to do the same thing for B, so watch the line pass through the graph. And notice at several points on this graph, it passes through more than one point. Where it stopped right now, it's passing through 3 different points. So B is not a function. If you'll watch C, at no point through that graph does it touch more than one point, Let's go ahead and check D. And D, it does pass through more than one point on the graph. Notice on D also, each of those segments has little arrows on the end of it, meaning that these are lines that are going to extend on in both directions forever. So actually any vertical line that passes through that graph would be touching 2 points on the graph. So D is not going to be a function. My answer here is C. The domain of a function is the set of x values of a relation. The range is the set of y values of a relation. Really quickly, remember that an ordered pair is in parentheses and it's x comma y. So x would be my domain values and y would be the range values of a set in a relation. If you look at this example, It says which set of numbers represents the domain. Domain means we're talking about the x values in each ordered pair. So I'm going to go ahead and highlight my x values. They would be 0, 2, 4, 4, 8, and 8. When a domain or range value is repeated, like here I have 2 4s and 2 8s, I do not need to write them repeated when I am just stating the domain of a relation. So here, even though there's even though there's 2 4s that are in the domain, I'm only going to write 1 4 when I bring out and write the domain. So the set that has 0, 2, 4, and 8 here is B. The next example says which set of numbers represents the range. When I'm talking about the range, I'm talking about the y values or the second numbers in the ordered pair. In this case, it would be 1, 2, 3, and 4. Nothing is repeated, so I don't really need to worry about that. And the set of numbers that includes 1, 2, 3, and 4 is C. The next example says the table shows a relationship between x and y. Which set represents the range? Remember, the range is the set of y values, so I'm going to highlight the y column. And again, I have 3 different 3s here, but I don't need to write 3 3 times. I just need to include 1 3 in my set for the range. So we write these just in numeric order, going from least to greatest. So I need a -4, which takes out B. I need a -1, which already gives me my answer. A includes -4, -1, 0, and 3. The next, it says for a set of ordered pairs to be a function, each input or domain value has to have exactly one output or range value. Remember mapping diagrams, and we've actually already done this in a previous example. They just already gave us our mapping diagram. So it says which set of ordered pairs represents a function. So it gives us sets of ordered pairs. What I'm going to do is I'm going to go ahead and take those ordered pairs, figure out their domain and their range, and make a mapping diagram. A's mapping diagram, A only has a domain of 2. Notice all of my x values are 2. And then the range would be 1, 2, and 3. When I draw my mapping diagram here, notice that the domain value 2 has 3 range values, so A is not going to be a function. When I map B, it has 2 domain values, 4 and 2. It also has 2 range values, 4 and 2 again. Be careful here when you draw your mapping diagram. The domain value 4 would be mapped, we need to draw an arrow to 2 because my first ordered pair is 4, 2. For the domain value 2, I would need to draw an arrow to 4 because my second ordered pair is 2, 4. And then again from the domain value 4, I would need to draw an arrow to the range value 4 because my third ordered pair is 4, 4. When I draw those arrows and make my mapping diagram, you'll notice that the domain value 4 has 2 range values, 2 and 4, so this cannot be a function. My mapping diagram for C, I have domain values of 0 and 1. I have range values of 0, 1, and 1. When I draw my arrows for my mapping diagram, notice both domain values have more than one range value, so it's not a function. D is my only choice left, but I'm going to go ahead and double check it. Each domain value has exactly one range value. My ordered pair, I would draw a line from 1 to 1 because I have the ordered pair 1, 1, 2 to 2, 3 to 3, and 4 to 4 because that's what my ordered pairs tell me in that set. So my answer here is D. A says which set of data represents a function. If you notice, I'm not going to do mapping diagrams here. I'm just going to kind of talk through it. You could make mapping diagrams. If you look at A, we have one domain value 3, and I have 4 different range values, which means that the domain value 3, or input 3, is going to have 4 different outputs. So A is not going to be a function. If you look at B, you have two domain values, -2 and 0. Each one of those have two different range values, which means that it's not going to be a function. If you look at C, they try to be really tricky. Notice we have input values of 0, 2, 2, and 5. And then we have output values of 8, -1, -1, and 4. Don't let them trick you, because if you notice, the two domain values, 2, have the same range value, -1. So that would be just considered the same ordered pair. So C is actually not out. And D, we have the same domain value 1 and 1 with two separate input values 0 and 1. So D would be out, so C is my answer. This example says, John owns a window cleaning business. He charges different prices for cleaning windows of different sizes. What are the independent and dependent variables? Really quickly, if you just read the choices, independent variable window size, dependent variable type of business is what A says. The fact that John owns a window cleaning business is not actually part of this relation that we're talking about. We're talking about different prices for cleaning different sized windows. So anything that says type of business that he owns is going to be out. So A and C would be out. Now, if you think about, he charges different prices for cleaning windows of different sizes. If you went up to John and you asked him, how much would you charge to clean my window? He would probably say, well, it depends on how large it is. So depends would be dependent. So his price is going to depend on how large or small your window is. So my best answer here is B. Unless you're building a house from scratch, you're not going to be able to choose your window size, and then his price is going to be based on how large your window is. So independent would be the window size. That's something that's not going to change. And dependent would be your price charged, because the price is going to change depending on how large your window size is. This next example gives us a graph, and it says the graph shows the average squirrel population in a city park from the years 1970 to 2000. What are the domain and range values of the data shown on the graph? If you look at this graph, and let's talk about domain values first. Domain has to do with the x-axis or x values. So if you look at the horizontal axis on the bottom, you'll notice that this graph goes from 1970 to 2000. So my domain should be greater than or equal to 1970 and less than or equal to 2000. So A and D are both out. They have the wrong domain values. My range values have to do with the y-axis, or the y values. When I look at the y-axis, the smallest range value would be right between 500 and 1,000, and the largest range value is going to be at 4,000. So my range needs to go from somewhere between 500 and 1,000. And if you look at your choices, B says the range goes from 0, and C says the range starts at 700. So my best answer is going to be C, the domain of 1970 to 2000, and the range of 700 to 4,000. The next example says, what's the value of x when y equals 0? Well, when they tell me y equals 0, that means I should substitute 1 for y. So I have 1 equals 2x minus 5. Now it's just a two-step equation. Add 5 to both sides, and you get 6 equals 2x. Now I need to divide both sides by 2. And when I divide both sides by 2, 6 divided by 2 is 3. So my answer is D. This next example says, what is the value of y when x is 2? We'll look at your graph and find the point where x equals 2, and the corresponding y value would be A4. The next example says it gives us f of x equals x squared minus 3x, and it says what is the value of f of 5? Remember that the f parenthesis x is called function notation. That's nice because it tells us automatically that this is a function. And then when it says f of 5, when 5 is in the parentheses, that's telling you to substitute 5 for x. So when I substitute 5 for x, I'm going to put it in parentheses, just like when I'm substituting anywhere else. I put 5 squared minus 3 times 5. Well, 5 squared is 25, and 3 times 5 is 15. 25 minus 15 is 10, so my answer is C. This next example says the graph of the function y equals f of x is shown. What is f of negative 3? Well, f of negative 3 tells us to look for x equals negative 3 on the graph. If you notice, the point where f equals negative 3 is right there at that pink point. And when x is negative 3, y is 2. This example says the function f of x is linear. It gives us a table of the values, and it says what is the value of f of 2? Now, the piece that's important here is it says that the function f of x is linear, which means that the x's are going to increase at a constant rate, and the y's, or the f of x's, are going to increase at a constant rate. So first, find the pattern of the numbers that they give you. The x's are increasing by 1. The f of x's, or y values, are increasing by 4. They want to know when x equals 2, what f of x is going to equal. I'm just going to go ahead and extend my table because I'm so close to 2 anyways, and I'm just going to repeat the pattern. So when x is 0, I'm going to increase it by 1. And then I'm going to go ahead and keep the pattern going until 2. And then I'm going to do the same thing for the f of x's. So from negative 1, I'm going to increase by 4, and I get 3. Increase by 4 again, and you get 7. So my answer here is D7. This last example says if f of x equals 2x minus 5, which expression represents f of x plus 1? Instead of now plugging in a constant for x, I'm going to plug in the expression x plus 1. Whenever I do that, I need to keep it in parentheses, just to make sure that if I have to distribute or multiply by something, then I'll multiply everything that needs to be multiplied. When I plug in x plus 1 for x, I'm going to have 2 times, in parentheses, x plus 1 minus 5. I do need to distribute the 2 to both x and 1. When I do that, I get 2x plus 2 minus 5. 2 and negative 5 can be combined because they're both constants, and I get 2x minus 3, so my answer is A. This is the end of Standard 2, Objective 1, Relations and Functions Notes.